Good morning, students. I hope you have understood the previous two chapters properly. Now it's time to begin lecture 1 of mathematics class 8 with chapter number 10, visualizing solid shapes. Students, you have learned about 2D shapes, which are plane figures, and 3D shapes, which are solid figures. Their nets for 3D shapes, how to draw 3D shapes on a flat surface in your previous class. Now, in this class 8th, we will recall 2D and 3D shapes. We will identify and match the pictures with joint 2D shapes and joint 3D shapes. We will visualize, as the chapter name indicates, visualizing solid shapes. We will visualize the 3D objects from different angles such as front view, top view and side view. Coming to the topics to be discussed in this lecture. First is I will introduce this chapter to you, that is visualizing solid shapes. Types of shapes or figures we will learn in this chapter. Examples of 2D and 3D shapes. Formation of 3D shapes, how the 3D shapes are being formed. Views of 3D shapes, how the 3D shapes or how can we visualize the 3D shapes from different angles. Now, introduction part. What are solids in mathematics? We need to, as the chapter name is visualizing solid shapes, first of all we need to be clear what are solids in mathematics. Shapes, everyone knows, these are the figures which we deal, like it can be triangle, rectangle, square, cube, sphere, all these come under the category of shapes. But there is a difference between 2D and 3D shapes. And what are these solid shapes? To understand solid shapes, we should be aware about dimension. So what do you mean by a dimension? Dimension is a measurable length along a direction. Dimensions are length, breadth or height. Dimension is basically a measurable length which you can measure along a direction, and it can be length, breadth or width or height, that is depth. A point is dimensionless. This all of you know, that if I am making a point on a piece of paper, then it has no dimensions. So a point is dimensionless. I am repeating it. Dimension is basically a measurable length which you can measure along a direction. Dimensions are length, breadth or width or height or depth. A point is dimensionless. Based on the number of dimensions a figure has, there are one-dimensional figures, two-dimensional figures and three-dimensional figures. And along with this, we should be aware about volume. What do you mean by volume? Volume is basically the measurement of total space occupied by a solid. Volume is the measurement of total space occupied by a solid. How much space is being occupied by a particular solid, that will be calculated by calculating its volume. Coming to area part. Area is the measurement of space enclosed by a closed geometrical figure. Like you must have seen a rectangle, and definitely it has some area, and we know the formula of area of rectangle, that is length into breadth. So that is the measurement of space enclosed by that particular geometrical figure, which is a rectangle in this case. So volume is the measurement of total space occupied by that solid, how much space is being occupied by a particular solid, and area is the measurement of space enclosed by a closed geometrical figure. Now, coming to shapes or figures. So we have one-dimensional figures, that is 1D, that is one dimensions. What are one-dimension figures? As the name indicates, the figures only having one dimension. Figures having only one dimension. So they do not enclose any area and have only one direction. It can be a ray or a line segment. So what are one-dimensional figures? The figures having only one dimension and they do not enclose any area and have only one direction. A ray or a line segment comes under the category of one-dimensional figures. That is 1D. One-dimensional, D stands for dimensional. One-dimensionals. Then we have two-dimensional figures. Basically, how can we get two-dimensional figures? Using one-dimensional figures, we can get two-dimensional figures. So they have an area associated with them, that is rectangle. It is a two-dimensional figure. It has length as well as breadth. Square can also be also a two-dimensional figure. It has also some area associated with it. Pentagon, likewise pentagon, hexagon, octagon, a circle, all these come under the category of two-dimensional figures or two-dimensional shapes. They have length and breadth or width. Definitely it has two dimensions, that is why they are two-dimensional figures. They are usually plane figures like squares, rectangles, triangles and circles. So what are two-dimensional figures? The figures or the shapes having only two dimensions. It can be length and breadth or width, and they have an area associated with them. They are usually plane figures like squares, rectangles, triangles, circles, pentagon, hexagon, octagon. Likewise, you can take more examples. Like I have seen you the examples rectangle, circle and triangle. So one-dimensional figures, they do not have any area associated with them. They can be used to make two-dimensional figures. Two-dimensional figures, they have an area associated with them which has two dimensions like length and breadth or width. Now coming to three-dimensional figures or shapes, three-dimensional shapes or figures can be made using two-dimensional figures. I can stack the two-dimensional figures either linearly or in a circular manner to get the three-dimensional shapes. It will be more clear to you later on in the further slides. So, first of all, understand what are three-dimensional shapes. 3D, it must be having three dimensions. D stands for dimensions. Shapes which can be measured in three directions are called three-dimensional shapes. These shapes are called solid shapes. So here, what do you mean by solid shapes? Three-dimensional shapes are the solid shapes, and in this chapter, we need to visualize three-dimensional shapes or three-dimensional figures or three-dimensional objects. So length, width and height or depth or thickness, height can be or depth or thickness are their dimensions. So three-dimensional shapes, how we will get it? By stacking the two-dimensional figures or the shapes in linear fashion or in linear manner or in a circular manner. These shapes which can be measured in three directions are called three-dimensional shapes. Obviously, three dimensions should be there. These shapes are also called solid shapes. So here, as the name of the chapter is visualizing solid shapes, so we will deal with three-dimensional shapes, three-dimensional figures in this chapter. We will recall, we have recalled two-dimensional and three-dimensional shapes. We will identify and match the pictures with joint 2D shapes and joint 3D shapes. We will visualize the 3D objects from different angles in this chapter. So our basic aim is to learn more about three-dimensional shapes, and three-dimensional shapes are formed using two-dimensional shapes. Two-dimensional shapes are formed using one-dimensional shape, one-dimensional figure or one-dimensional shape. So length, width and height or depth or thickness are their dimensions. Examples can be cube, cylinder, cone, cuboid, spheres, etc. You can see cuboid and cube. These are the three-dimensional shapes because it has length, breadth and height. More examples can be hexagonal prism. It is also a three-dimensional shape. Sphere, cylinder, cone. These are the examples which are the examples of three-dimensional shapes. The more examples, a number of examples can be found in everyday life. Some of them I have tried to show few of them here in this slide. First one is Rubik's Cube. You must have seen or you must have used it. And next one is drum. Then it can be a birthday cap also. Then you can look it as a cone, inverted cone, or it can be a birthday cap. And last one is the orange, which you eat normally in your daily life. And another example you can take is the room in which you are sitting is an example of three dimension. It has length, breadth and height. Or the laptop screen which you are looking at, is also an example of three-dimensional figures. So likewise, in our vicinity, we see several objects or several 3D objects. Now, the 2D shapes and 3D shapes shown above are single, but in our vicinity, we see several objects which are the combinations of different shapes. It can be so that the objects which I am looking around can be a combination of 2D and 3D shapes. Let us take the example, a window and a photo frame. This is a window. This is a photo frame. Here, in the above figures, we can see the combination of different shapes, 2D and 3D shapes. Like a window, in a window, rectangle is surmounted by a triangle. A photo frame, in a photo frame is the combination of two rectangles forming a rectangular path. Now, how these solid shapes are being formed? As I told you earlier also, to make solid shapes, what are solid shapes? Three-dimensional figures or three-dimensional shapes are called solid shapes, and which has 3 dimensions, that is length, breadth or height. And how they can be formed? Stacking of 2-dimensional figures results in solid shapes. For example, linear stacking of circles forms the solid shape called cylinder. Likewise, if you will keep on stacking the circle in linear manner, then you will be able to get a cylinder. So, stacking of 2-dimensional figures results in solid shapes. Solids are 3-dimensional shapes. Linear stacking of the circles forms the solid shape called cylinder. If I will keep on stacking the circle, I will be able to get a cylinder. Another example can be of a solid cuboid. How solid cuboid can be formed? A cuboid is a solid bounded by 6 rectangular plane regions, and we know that rectangle is a 2D shape. So again, this is a cuboid is a 3-dimensional shape, and so this cuboid is a solid bounded by 6 rectangular plane regions. It is also formed by stacking rectangles linearly. Like if I will keep on stacking the rectangles linearly, then you can imagine this also, then you will be able to get a cuboid. I hope with these 2 examples you have understood how we can stack 2D objects or 2D shapes to get 3D objects or 3D shapes. Like in case of if I will keep on stacking the circle, then I will be able to get a cylinder. Like here in this case, if I will keep on stacking the rectangles linearly, then I will be able to get a solid cuboid. Solid cuboid, that is a 3-dimensional cuboid. Now, perspectives of looking at a solid. Now, these solid objects, if they are being looked from different angles or different views, their views will be different. Like in the previous class also, you must have learned that 3D objects can have different looks from different positions, so they can be drawn from different perspectives. And when we see at a solid object, it is not necessary that whole solid object can be seen from one position. The view of the solid depends upon the position from where it is seen. That is, when we see at a solid object, it is not necessary that whole solid object can be seen from one position. The view of the solid depends upon the position from where it is seen. So we can say that a solid can be seen from different angles having different looks. Like it can be seen from the front, side or top. Any 3D object when viewed from different positions might appear different. Few examples can be, I have tried to show you a few examples. First one can be, look at the different views of a glass from different positions. If this is the glass, and if I will look at this glass from the top, then I will be able to see a circle. This is the third figure. If I will be looking at this glass from the side, then this second figure will be your side view. So when we see at a solid object, it is not necessary that whole solid object can be seen from one position. The view of the solid depends upon the position from where it is seen. It can be seen from the front, side or top. So in this chapter, we need to deal with the different perspectives of 3D objects. It can be viewed from the front, it can be viewed from the side, it can be viewed from the top. So we need to show the front view, side view or top view. Looking at different views of solid made of 4 cuboids. Here, this is the figure made of 4 cuboids. Then, what will be the side view of this? The side view will be 2 rectangles. Side view will be 2 rectangles. So, in the side view, we have made 2 rectangles. Front view is the 3 rectangles. Top view will give you 3 rectangles and 1 at the back, that will be 4 rectangles. You can take it, this solid, as a cuboid, or it can be a cube also. So likewise, if it is a cuboid, then it can be a rectangle. All the side view, front view and the top view will have rectangles. If it is a cube, then it will be having squares. Looking at this dice, you must have used it in playing Ludo or any other game. Then what will be the top view, side view and front view of this? So front view, obviously if I am looking at this from the arrow which indicates the front view from this side, then it will have 3 dots. Side view, it will have 1 dot, and top view, obviously it will have 2 dots. It is quite clear in this figure. Coming to fourth example. In this example, front view, side view and top view. If I am looking at this figure from the top view, then these 2 rectangles will be shown to you. It is clearly mentioned in the figure from where you need to see the figure from the top, from where you need to see the figure from the side and the front view likewise. Then in the side view, you will be having these 2 figures, and front view will be having as shown in the above figure, that is clearly mentioned from the top, side and front view. So here, homework from the NCERT. Exercise 10.1, you are supposed to complete question number 1 to 3 in the book and question number 4 in homework notebook. In question number 4, you are supposed to make the different views of 3D objects given in the question. So question number 1 to 3, you are supposed to do in the book. Question number 4 is to be done in the homework notebook. So we have learnt in this chapter that we have recalled, first of all, we have recalled about 2D and 3D shapes. We have tried to visualize the 3D objects from different angles such as front view, top view and side view. We have learnt about the dimensions. What are dimensions? And dimension is basically a measurable length along a direction. Then we have learnt about 1D, that is one-dimensional objects, two-dimensional objects, three-dimensional objects, and we have tried to look how we can form three-dimensional objects from two-dimensional objects by stacking them in a linear manner or in a circular manner. And then we have learnt at the end how to visualize the 3D objects from different angles such as front view, top view and side view. I hope all these concepts are clear to you, and on the basis of the concepts discussed here in this lecture, you will be able to solve these questions. Thank you so much.